Lesson 2, powers and exponents. All right, so some of this will be review, but it's important review because our next couple lessons are going to be building on our understanding of powers and exponents. All right, so let's look over our objectives. You are going to need to know and apply the properties of integer exponents to generate equivalent numerical expressions. Write equivalent statements. Doesn't have to mean simplify writing those, okay, and rewrite perfect squares and cubes as a product of a common factor. All right, so that means how could you turn 27 into a power? What's an equivalent expression but using a base and an exponent? So how can you write 27 using a base and an exponent, or as a power? It would equal 3 to the third, or 25 would equal 5 to the second. All right, so let's get moving. Here's our vocabulary for the day. It's already written out for you. A product of repeated factors can be expressed as a power, that is using an exponent and a base. So this right here, that is called, the whole thing is called a power. And there's two parts to a power. There's the base, which is the common factor. That's the repeated factor. And then the exponent, which tells you how many times the base is used as a factor. I really like that explanation. I think it's clear. I think it's simple and useful. All right, so let's get started on our examples. All right, so it says write each expression using exponents. All right, so we want to in this case, write it in the most simple version, but there's tons of versions we could write that would still be equivalent. So we see that we have 3 of the exact same factors, so that will be one of our bases. And since we used it 3 times as a factor, we use the exponent 3. All right, now we find another common factor here. So that factor is a 3. And how many times did we use it as a factor? 4 times. So that is the original expression written with exponents. All right? I'm sure you can get this next one by yourself, but I'll go through it anyway. Commutative property says I can move these values around so that we can have the common ones next to each other. So I find the A and the A. If we put those next to each other, we notice that that factor is used twice. And then we don't need the dot here because we have variables, so we can just find our other common factor, which would be B. All right, and so we put that as our base, and how many times is it used as a factor? 3 times. All right, now try these got it's. Why don't you go ahead and pause, try these got it's, and then check and see how you're doing. All right, really pause. Okay, pause and do them, and then come back and check your work. All right, so what is, for part A, what is the factor that's used repeatedly? It is 1/2. So that's going to be our base. Now it's important with fractions to put that whole fraction in parentheses. All right, if you didn't do that, fix that now. And then the exponent goes outside of those parentheses. So how many times was that 1/2 used as a factor? 4 times. All right, the next one, you see that there's 4 is the repeated factor, and it's used 3 times. And we're going to multiply that by 5, and that factor is used twice. All right, and final one, we have m is used as a factor 3 times, and n is used as a factor 2 times. All right, hopefully you did all right. Let's move on. Now evaluate. Evaluate means simplify, all right? So actually find the results. Find the result. So now, you might quickly see, okay, well, whoops, I'm getting ahead of myself. So let's evaluate this fraction here. Okay, so this 4 tells you how many times to multiply the base of -2/3. All right, so that's going to be -2/3 times -2/3 times -2/3 times -2/3. All right? So essentially, it is saying, well, multiply 2 by itself 4 times and multiply 3 by itself 4 times, all right, to get our answer. So this would be 2 times 2 is 4, times 2 is 8, times 2 is 16. Now we have, I'm going to do this a little bit differently. I'm going to go that 3 times 3 is 9, 3 times 3 is 9, and then multiply those up and get 81. Now, can anybody tell me, is this going to be positive or negative? All right, you might remember from the past that if you have an even number of negatives, that's 4 negatives right there, so that's an even number, that are being multiplied, then you're going to get a positive answer. And if you have an odd number of negatives, which we don't in this case, we do not have an odd number of negatives, it's going to be negative. So this is going to be a positive answer, so that is what we get when we try to evaluate that original expression, negative 2/3 to the 4th power. All right, now go ahead and do the got it's. All right, if you have to do a little scratch work on the side, for instance, 4 to the 4th, all right, this one here, 4 to the 4th, the numbers get a little bit big, but you do some scratch work, see if you can get it right, and then unpause and check to see how you did. All right, so this would be 4. Now, quickly, if you're just doing it quickly and don't pause to really think about what a power is, you might say that the answer is 16. What do you think I did there? I accidentally just multiplied the base and the power instead of actually taking that base to the exponent. So using that base as my repeated factor 4 times. Now you could do it a bunch of different ways. You could do 16, and that's 16, and now multiply 16 times 16. All right, that's going to be 90. And 160, so that gives us 256. All right, so the answer there is 256. Now, notice take careful notice of letter E here. All right, take careful notice here. Notice that the negative sign is inside these parentheses. So that negative symbol is being taken 6 times. All right, is used as a factor 6 times. So a negative times 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 a negative. All right, what would you get if you have an even number of negatives? Remember, you get a positive. So our answer is going to be positive, and we don't really have to deal with the negatives now since we already have figured that out. All right, now I'll write them in case you want to kind of look at it. 1, 2, 3, 4, 5, 6. Right? If you can see, this would be positive, this would be positive, this would be positive, right? Since a negative times a negative is a positive. So then you can see that it for sure is going to be, a positive answer. All right, excuse me. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. That's going to be positive 64. All right, and 1/5 to the 3rd is 1/5 times 1/5 times 1/5, which essentially you just do the top times itself 3 times and the bottom times itself 3 times. Careful, a lot of people would put 3 at the top, right? But it's not 1 times 3, it's 1 times 1 times 1. So that will give us 1 at the top. 1 to any power is going to be 1. All right, so let's go with 5 times 5 is 25, times 5 is 125. All right, so there we go. We're moving on. Let's look at number 4. Read that over yourself. All right, it says what is the area? So basically we're going to be evaluating this. All right, we're just going to take 2 to the 5th and then multiply it by 7. All right, 2 times 2 times 2 times 2 times 2 times 7. So let's go with the 2's first. 2 times 2 is 4, times 2 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we got to do 32 times 7, 4, 1, 224. 224, and that's going to be square inches. Circle our answer. All right. It's going to take some scratch work here. All right. So to practice this, you're going to have to do some scratch work. I'm going to skip over part G. All right. Just to get us moving a little bit. All right. Evaluate, and we have some numbers to substitute. That's a great word for 8th grade. Substitute means replace, just like you replace me if I'm out sick with another teacher. All right, we have a squared plus b squared. One important thing, when we substitute with exponents, please put the number in parentheses, especially if it's negative. So I'm going to take out the a and put in parentheses in its place. I'm going to take out the b, put in parentheses in its place. All right, it does not have a huge effect on it if what we're substituting are positive, but it does if it's negative, especially if you're using a calculator, or if you're trying to communicate with somebody, how you want it to be done. Because if you're not careful, they'll get the wrong idea. All right, or order of operations will be messed up. So we put what we substitute in parentheses. So a is going to be 3, and b is going to be 5. All right, let's follow order of operations, which I like to use G, E, M, S, gems, grouping symbols, exponents, multiplication, and division, and then subtraction and addition, left to right. Okay, so there's no grouping symbols. There kind of is, but nothing inside the grouping symbols that has to be done first. There are exponents. So 3 to the second means 3 times 3, so that's going to be 9, plus 5 to the fourth. I know that 5 times 5 times 5 times 5. I know that this gives me 25. This also gives me 25. And 25 times 25 is going to be 125, 50, so that's going to be 625. Now we're going to add those up, and that gives us 634. All right, so when we evaluate, we're getting the simplest answer that we can. Try number 6. Why don't you pause it, try number 6, and then check your answer and fix it if you got it wrong. All right, back at it. Here we have number 6, so that's going to be, we're going to replace a with 3 and b with 5, and we're going to follow our gems again. So we start with grouping symbols. Hey, we have something inside grouping symbols now. We have these to complete before we take it to the exponent. So 3 minus 5. All right, if we start at 3 on the number line and go left 5, that's going to end us at -2. So we have -2. Now that's still in parentheses because we simplified what's in there, but we still have this exponent out here to handle. So if there's an exponent outside, keep these guys in parentheses to make sure that we do the right thing. We want this whole thing to be taken to the second power. All right, so that's -2 to the second, so that means -2 times -2. If you have to write it out, go ahead, but -2 times -2, a negative times a negative is a positive. 2 times 2 is 4. All right. Okay, go ahead and try these Goddard's H, I, and J on your own. Oh, before you press pause, check this out. That is a tricky one. They put this in there on purpose to challenge you, but the -4 needs to be placed in parentheses when you substitute it in. All right? So, for instance, for part H, when you take out the C, put parentheses in. All right? And make sure that -4 gets in those parentheses. All right? Okay, that's going to be a negative times a negative times a negative. So that's going to be a negative answer. All right, and then 4 times 4 is 16 times 4 is 64. Remember, I know I'm doing this in my head. I've had more experience than you. If you have to, go off to the side and do some scratch work to get those answers. All right, this is our first case of having an odd exponent with a negative. Remember, if we have an odd number of negatives, you're going to get a negative answer. Okay, 9 to the second now is 81. That's 9 times 9. And now we have to add. All right, I see I'm going to start at negative 64, and I'm going to go to the right 81. Okay, if you envision that on a number line, it's going to start all the way to the left of 0, way far down at negative 64. But then it's going to start hopping back to the right towards 0, and then past 0. Right? You have to envision that so you can kind of understand what's going on here. So 81 hops to the right. Okay, it's going to take, after 64 hops, it's going to be at 0. Then how many more hops will it go into the positives? So what we really have here is a subtraction problem that's going to go 81 minus 64. Okay, how much further into the positives is it going? That's going to give us, okay, positive 17. All right. Let's try I. So we have negative 4 plus 9. That we follow order of operations, do grouping symbols first. Negative 4 plus 9. That gives us 5. And then 5 to the third power. 5 times 5 is 25. 25 times 5 is 125. And our final problem. Sorry, I jammed it in here. My screen's kind of small that I'm writing on. Okay, part J, d to the third. So that's going to be 9 to the third minus parentheses. Ooh, man, we got all sorts of good stuff going on in this problem. C squared, remember that negative we got to put in parentheses, and then minus 2. All right, we're going to get some big numbers. It's okay. We're going to do parentheses first, so that's over here first. Okay, inside those parentheses, we follow order of operations again. So I like to bring down whatever I'm not working with. All right, now, a negative 4 to the second. Okay, that's going to be a negative times a negative, so it's positive. And then we have positive 16. Bring down the 2 and put my parentheses in. I think I put an extra parenthesis over there. Oh, it's just because I did that. Okay, now I have to still simplify, show each of your steps here. Don't skip too many in your head. 16 minus 2 is 14. All right, now I can move on. I can finish my grouping symbol. Now I can go on to the exponent, GEMS, GEMS. Okay, so this is 9 to the third. 9 times 9 is 81, but do some scratch work off to the side. That's 729. So 729 minus 14, and we get 715. All right, so we're moving along, not too bad, and we are finished. So hopefully that wasn't too terrible. There are some really important steps, like when you have a negative that you have to substitute, especially with powers. Make sure you keep that in parentheses, and it'll help you just keep track of everything. Show all your steps, and good luck with the homework.